16? Yeah, 16 bytes long. Okay? Because it's 128 bits long. That's 16 bytes. That's not right. Yeah, that's right. 128 bits. I'm doing wrong numbers in my head. Sorry about that. Alright, the next thing. The opcode. Is this an ARP request or an ARP reply or a RARP request or a RARP reply? Now, what's RARP? They tell you after all of this of using the letters, then they tell you what RARP is. RARP, R-A-R-P, is Reverse Address Resolution Protocol. What that does is goes in the opposite direction of ARP. Well, guess what? Most of the time we want to take the IP address and get the MAC address. So that means we use ARP. Think about which one are you most likely to use, and that's going to go with ARP. The other one you don't very often use, but you may need to use at some point, or that your system may need to use. RARP is also available there. It will take a MAC address and find out what the IP address is. You know what the MAC address is, and you want to know what the IP address is. Well, there's not very often you want to know that. But it gives you that ability. Now, what else can you compare RARP to? Some of you are using the internet now to do this, but prior to the internet, you had to go get a separate book to do this. Think about phone books. What's the normal phone book going to give you? You look up the person's name and you get their phone number, right? Is that always what we want? No, occasionally we got a phone number and we want to know whose phone number is it. So you want to do a reverse lookup in the phone book. Well, the phone book doesn't give you that ability. They actually used to publish, and I assume they're still publishing, but I haven't gotten an ad for one in a while, phone books that listed all the phone numbers by the number, and you go through and look for a number because they were all in order, and then it told you all the other information that you had normally in the book, but it was sorted by numbers, not by names. Or the other place you can go with that one, assuming people haven't moved their information to where it's not public information any longer, is you can go out onto the internet and find places that will allow you to do the same thing to it. And that's been a real popular one of people to use on the internet early on, was where they could go look up phone numbers on that. Because people are always getting frustrated. I've got a book I had bought back in the late 80s for Swainsboro, Statesboro, and a couple other towns that gave all the numbers in numerical order instead of in alphabetical order. That way when there were messages left for me, because I don't know what it is about some people they'll call and just leave me their phone number and assume I remember who they are by their phone number. And I have to try to think, alright, whose phone number is that? And I can look it up and find out. At least it would tell me the address in that book. It wouldn't tell me the names, I don't think it was, if I remember right, but it would give me the address. And so then I could figure out who it was. It must have given names too, but I don't remember. But RARP can be handy at times that you want to reverse lookup. So, if you're going to do an ARP, what happens out there, if you're ever trying to do an address, when you go to send out something, you're on your web page and you type in www.dwightwatt.com. Okay? It does not go to wherever my page is stored at. In New Jersey or wherever that page is actually stored at. Or to Arizona and then to New Jersey. Just off of there, it's going to go through several steps in the process. One, it's going to take that domain name and it's going to go out and look up through the DNS service and find out what the IP address is. So it's going to convert my name, www.dwightwatt.com, to some number and give us that regular IP address. Numbers dot numbers dot numbers dot numbers dot numbers. Then it's going to use ARP. It's going to make an ARP request with that number it found to find what the MAC address is. It's going to make a request, and it's going to find out the MAC address of where the machine is that address is stored. And so it's going to find out at that point that the machine MAC address of the machine sitting there in Arizona. At least that's where I assume the machine's sitting. And return with that. Now it may not return immediately with that, because bear in mind the order it goes through, all it's got to know is the MAC address of the next router it's going to. The MAC address of the next router. So it's going to do it numerous times, that ARP request, till it gets there. I had to do that DNS request one time, figure out what the final spot was for that. And once it gets to there, because I'm doing a forwarder, gets to there and it says, oh, you want to go to New Jersey to find him. Or at least I think that's where that machine is, where my home page is. But that's where it was at one time, so we'll assume it's still in New Jersey. Then when it finally gets to New Jersey, then it sends it back to us, wherever you asked for it in the world. So it's going to send it out and make a request and then get it back. And keep getting that information it goes till it finds the actual MAC address. Great. Questions on ARP? Major thing on ARP is to realize it's IP addresses to MAC addresses. RARP to do MAC addresses or physical addresses to IP addresses, or the other way to think about it is physical addresses to logical addresses. Okay? So as you pass it out, keep in mind you're making broadcast out when you make an ARP request. But what's going to happen when the ARP request is made? Once you make an ARP request as a broadcast, what's going to be the reply? Is it going to be a broadcast?
Unicast.
It's going to be a unicast. Why is it going to be a unicast?
Because it's directed to one.
It knows who sent the message out to everybody, so it can respond back just with that. I can do a broadcast to all of y'all of how many of you want to come over and have steak Friday night. Well, all of y'all are going to go, I don't think we want to broadcast this back that I'm coming. That not everybody needs to know who everybody's coming back, so you can send a directed reply back to me to say, yes, I'm going to be there, and 9 of my friends are coming with me. And so hopefully that I've bought a ranch and got enough cattle there to kill to feed y'all all steak Friday night. But tough luck. I don't have any steaks at the house to feed y'all steaks Friday night. Alright, questions on ARP and RARP? Alright, IP. We already talked a good bit about IP, so there's really no reason to tell you anything about IP, because it's the same IP working right here on the internet layer as was working on the network layer in the OSI model. ICMP. We've briefly mentioned it a few times along the way, but we haven't talked a whole lot about it. But ICMP is going to be important to you to be able to do stuff, and also you need to be aware of ICMP because it's going to be important to know what it can do to you to be able to prevent you from having problems too. But ICMP can be a chronic problem of causing problems on the internet too. ICMP, Internet Control Message Protocol, is going to allow us to send out and get information about this stuff at places and get it back. We're going to be able to make requests of locations and get an answer back from it. So we're going to be able to do some of the things that we want to be able to test with ICMP. The big thing you're going to see in ICMP, as far as a message that you're going to encounter that's going to be a chronic one of always associated with ICMP, is the ping command. The ping command is going to allow you to determine connectivity to another machine. Also going to give you an idea of how fast is your connectivity there. But the major thing people are usually using ping for is to determine, do we have connectivity? So, if we ping it, we want to get a response back in terms of that. So the message format for ICMP is fairly simple. Only 4 fields to it. The first one is the type. So what type of message is this? Number 2, the code. What is the specific function of this message? Third one is the checksum, like we had back there when we talked about where 2 and 3 items. So we're going to checksum there so that we make sure what we sent out really did get there. And then the fourth one is that we can have data included on there. And that can be done. Okay? Now, we can use ICMP to determine the connectivity. We can use ICMP as our way to determine should we speed up or slow down our transmission rate. You got 2 machines talking back and forth to each other, transferring data. The receiving one goes, whoa, I'm getting it way too fast and my buffers are overflowing. It can send an ICMP message to the other machine and go, whoa, slow down. Just like when I'm delivering the lecture to you, that if I'm giving you the information too fast, you can tell me, no, you're going way too fast, let's slow down on this. And it can be the other way. Maybe I'm going to be sitting there going, we're bored to tears on this. Go ahead and let's get going. If it can't get to the end, it's going to send back a message in terms of what happened, of why it could not reach where it was trying to reach to. When it gets to a certain point and it goes